Thank you everyone for joining us for this webinar today. For this presentation today, we're going to be discussing the results of a survey that we conducted on future trends in operations and maintenance in the offshore renewables sector. I'd like to give a special thanks to our partners at Fugro and the members from our own offshore renewables special interest group for supporting this activity. So before we get started, I would just like to very quickly introduce my wonderful panel. And I'll obviously invite them all to introduce themselves properly when we get to the panel discussion. But just to welcome everybody who is online today. So Ivar, Josselin, the Solution Director for Remote Inspections at Fugro. He's been working in the offshore industry for over 25 years. And since joining Fugro, Ivar has supported new solutions in geophysical data acquisition and has been the driving force behind strategic partnerships in delivering remote and autonomous solutions to marine industries. Alice Gomez-Brown, she's the chair of our special interest group and a renewable energy consultant at Wood. Alice, over the last decade, has been building up experience in academic and commercial metocean projects and with a focus on marine energy installations and monitoring. Mark Calverley is also the other co-chair to our special interest group and the director at Blue Ocean Consulting. He himself also has over 30 years experience in providing metocean services to marine industries, primarily offshore wind, so delivering data to support design certifications and maintenance. And finally, Panos Stavrakakis, the head of organizational health and wellbeing with the Health and Safety Executive Science and Research Center. So Panos has background serving as a naval engineering officer and now currently working with HSE, provides regulatory insights to address occupational risks in marine industries. My name is Katrina Hanley and I will be facilitating this panel discussion today. So I guess just as a sort of brief introduction and why we did this survey, offshore renewable energy is a rapidly growing industry. It's going to be critical in the energy transition to achieve international goals to reduce emissions. And with growing interest in kind of the green recovery in a post-COVID world, there's kind of growing importance for the role of marine energy. And with infrastructure in offshore wind farms also being relatively new, there are sort of many new opportunities for innovations and technologies to drive improvements in efficiency in operations and maintenance strategies. So to be able to explore this topic, we partnered up with Fugro to run a survey, and we're then working with over 400 professionals across the sector, looking at topics around technology, skills, safety, and we were aiming obviously to investigate attitudes and perspectives of people working in the industry to consider their views on what opportunities offer the greatest potentials and what people think some of the challenges and barriers might be. And as I guess a reminder also to everybody watching that at the end of this webinar, a full report on the survey and a more detailed discussion on the results will be available to download. So jumping straight in then with kind of our overview of some of the key messages. One of the messages that came out was the expectation of growth in autonomous and digital technologies. So 88% of our respondents said that they think it'll have a significant impact within their own organisations. And there was quite a majority saying, there's a real drive for opportunities that are looking to reduce environmental impacts, so that there is a lot of interest in the sector at the moment. Developments in things like automated cloud processing are rapidly taking shape, and respondents considered a wide range of both kind of different technologies that are showing promise in the industry. So quantum computing, UAVs, augmented reality, which is a couple of examples, but also the different types of benefits that they think or impacts that these technologies could have. And again, examples included reducing unnecessary tasks and offering improvements to better manage stock. Interestingly, while it was believed that there is a clear future for new autonomous technologies in the industry, there was more uncertainty in the responses that we had around implementation. So we have been asking, obviously, how people thought a lot of these technologies could come into play. So would there be an incremental approach? Would there be semi-autonomous technologies to start with? and even looking at whether or not people felt there could be a differentiation between topside and subsea in terms of inspections and management, so that those different environments could be managed separately. And a lot of these were seen with kind of mixed views, with responses typically around or just under 50%. So there was a more kind of even split there. So that's, I think, obviously offers an opportunity for these technologies, I guess, to reach that sort of proof, I guess, stage, so that, you know, as it gets more integrated, then it will be taken up more. And as wind farms are developing, people are looking for the opportunities to start off from a strong position. So I think there could certainly be that opportunity to build up there. We also discussed or asked in our survey what people felt some of the main barriers were to introducing some of these technologies. So the key things that came out, or the highest ranking ones, were actually commercial readiness of technology and costs. Opinions very much differed on digital strategies as well. So while there is a lot of potential and benefit seen in them, there was, I think, a main argument that was put forward in expressing caution that the data-driven approach can't replace experience. So there's going to be a challenge in balancing intention versus implementation. So there's also growing interest in predictive maintenance. Digitalizing strategies could mean industry is moving away from more traditional continuous inspections. 76% of our respondents outright agreed that predictive maintenance will effectively reduce costs, which again was previously considered as one of the main challenges to overcome. Modelling tools and automated component prognosis could facilitate kind of the reduction in frequency and cost of inspections, and people really flagged that as a benefit. Comments were also raised, however, again expressing caution that models are obviously only as good as the feed data that are put into them, so that obviously has to be managed carefully. Some of the questions that we were looking at was trying to ask people to consider how their maintenance models or approach might change in the next 3 to 5 years. So this graph I have up in the middle of this slide here, on the left-hand side, we were looking at the types of models and approaches that people are currently using, and then on the right, what people are expecting or think they will be using in 3 to 5 years. So down at the bottom, we have reactive maintenance, which in general was quite low and showed little change. Moving on up from there, risk-based inspection approach, again, was showing a bit of a decrease. And the predictive modelling in terms of a sole use is, again, reasonably low, so currently around 12%, and is only seeing a very slight increase to about 15%. But the two kind of biggest chunks at the top of that chart there, so my top 2 bars, the second one being the continuous cycle of inspection and maintenance. So you've got just over 35% of people currently using that and expecting a decrease down to just 20%. And this top bar here is, I think, where we've got an interesting result, which is the idea of using both. So both risk-based and predictive modelling. Currently, around 36% of people say that that's the approach they're using. This is increasing to 56% in what people are envisaging for 3 to 5 years from now. So the views kind of suggest that predictive modelling won't be a replacement, I think, for some of the current practices, but it can certainly be incorporated to adapt strategies so that there are an improved efficiency in operation and maintenance. We're also obviously looking at several of the other benefits that people had raised, so beyond just the costs. One of the highest ranking things that have been raised in our survey is actually improved flow of data. So over the lifetime of a wind farm, data is passed between phases, design, construction, maintenance, extension, and also between different parties, developers, operators, service providers. So there were a few comments that were calling for streamlining, I guess, how data is moved between them, and streamlining the number of places where data is stored, so that could help better support data-driven decision-making. One of the topics that we also addressed in this survey was the role of metocean data. Provision of weather forecasting and real-time data can support work planning. So being able to determine when it's safe to conduct inspections, analysing performance and looking at how to better understand the impacts of localised events, validating models, supporting environmental impact assessments. And these can all be used to adapt operation and maintenance strategies. So respondents were typically in agreement that there could be new developments in how data is collected. So 77% of people think that more on-site sensors should be fixed during installation, and 71% believe that satellites will be increasingly used to support maintenance planning in the future. However, when asking then about the role of this data and the importance of like how that can be used, that's actually where we got more of a mixed result, which was interesting. So only 56% of people agreed that weather models will ultimately power an energy generation forecasting tool. So it could suggest a bit of a disconnect between the different parties involved, or just that some people don't consider this particular type of information as important a factor in, as important a factor to changing, how maintenance is managed compared to other technologies that were also discussed. So 44% of the respondents had agreed that improving forecasts will have an impact on costs of operation and maintenance. So again, that's reasonably low, but there was, in the comments that we received, a very kind of distinct difference between those emphasising the importance of this type of data to reduce risks and better support maintenance management, and those that didn't, either said that they didn't really understand it or just didn't think that it played as much of a role. It's probably also worth noting that a lot of this data can also be supporting other industries or other partners. Data being collected can be shared to support the needs of multiple sort of end users and applications. So there is also an opportunity there. So greater understanding of those data requirements would be helpful. And with all of the emerging technologies, there are also issues raised on where the gaps might be, as well as just where people think there are promising opportunities. So in particular in skills and in safety. So there's an expectation that there's going to be growth in lots of new tools, robotics, artificial intelligence, UAVs were highlighted as some of the key ones. And there were 24% of the respondents felt that the human-machine interface currently just isn't prepared for being able to meet the demands of the future in terms of ease of use. And a further 60% said that the industry that interface is really only somewhat prepared to be able to support people working in the industry. So there's a growing demand for upskilling the workforce, particularly in IT skills, such as programming languages was something that was a popular response in terms of the comments that we received to ensure that demands of the future can be met and support kind of the evolving role of marine engineers and other people working within the offshore wind sector. Now, the offshore renewable energy as a sector can benefit from skill transfer from other offshore industries, particularly oil and gas. So being able to mobilise supply chain services from downturning industries will then be able to better support the development of emerging industries and in particular offshore wind. And there was quite a few comments saying that there'd be a lot of strong synergies, I guess, between the opportunities for people who'll be working in offshore wind and other industries, so electrical engineers, shipping engineers, and that there is going to be a lot of opportunity there for people moving from one sector to the other. The use of remote tools is believed to reduce risks to a lot of people working in the fields, and largely from the perspective of taking people out of hazardous environments. But there was a fear, obviously, that technology is progressing faster than training can keep up with, and that people need to obviously be able to be properly trained with new complex systems in order to be able to operate them safely. and that we're not, in all likelihood, people aren't going to be removed entirely from the environment, or at least not in the immediate future. You've got improvements to diagnostics, but there will still, in some cases, need to be people in the field to either run these kind of technologies or be conducting inspections. So there was also comments raised on being able to support safety equipment development, as well as looking at other new technologies in development. And again, within our respondents, there were only 28% of people said that health and safety policies are very prepared to be able to support the needs of the evolving role of marine engineers. So that was another kind of key message that we identified, that those gaps in safety and skills will grow unless they're addressed at an early stage. So that was, like I said, very much a brief overview, and you'll be able to read full details in this report. But I want to be able to dedicate this time to our wonderful panel. So if I stop sharing my screen, my panel should hopefully now be online. So welcome, obviously, everyone, and thanks again for joining. If I could just do a very quick roundtable, just to give everybody a chance to introduce themselves. And I'll just wander around my screen. Ivar, let's say hello.
Hi, hello. Thank you for the opportunity to be here. Nice results. My name is Ivar Josselin. I'm working in the Fugro office in Holland, and lately mainly focusing on developing and rolling out remote and autonomy solutions in the offshore sector, with the obvious focus on O&M and offshore wind.
Thank you. Alice.
Good afternoon. So yes, I'm Alice Brown. I chair the ORSIG alongside Mark Calverley, and I'm a renewable energy consultant, specifically working in power performance testing at Wood, based in Glasgow.
Thanks, Alice. Mark.
Afternoon, Mark Calverley, Met-Ocean specialist primarily, but also experienced in innovation as an innovation manager, and also running an innovative monitoring program for NERC, looking at offshore renewables. Thank you.
Thank you. And last but certainly not least, Thomas.
Unmute myself. Hello. Thank you for the invitation. Many congratulations for this amazing survey and organizing this webinar. I'm Panos Stavrakakis. I work for the Health and Safety Executive, the UK national regulator for occupational health and safety. I'm part of the science division, the Science and Research Center of HSC. I lead the portfolio of organizational health and well-being, and I'm leading a scientific work program for the health and safety in offshore renewables.
Okay, thank you, and again, welcome all. So I guess just delving straight into it and being able to get your thoughts as our experts. Ivar, I think I will start with you. So obviously, offshore wind farms tend to have, I guess, very unique challenges in many ways for operation and maintenance efforts, just given the nature of the environment that they work in, and changing conditions that can affect performance all the time. So I guess in light of the study that we've just done, what methods and strategies are kind of out there for operators for managing offshore wind assets to optimize their power output?
Yeah, thank you, Alice. Interesting question. I think that in order to approach that topic in its whole, we need to look at the bigger picture. What are you talking about in operating an offshore wind farm? What's the framework in which you're operating? And that's, on one side, it's the turbine that generates the power, of course, which gets all the attention from the OEM, from the original equipment manufacturers, the turbine manufacturers. But on the other side, it's also the environment in which the wind farm is situated, is built. The mid-ocean environment and the geo environment where this wind farm is positioned. I think that if we look at O&M challenges, that we are facing a supply chain that is focusing on their own space in that respect. The OEMs are focusing on the turbine, and the supply chain that's focusing on the balance of plant activities is focusing on the other parts of the wind farm. I think that the biggest opportunity to move ahead in that space is by providing a broader insight in how these two environments interact with each other. So the balance of plant data and the operational technology data that are describing the turbine operations. So in that respect, I think that moving to a situation where full insight is provided to the operator, and by running analytics and moving to more condition-based maintenance in that respect, I think that there are the biggest opportunities at this moment.
Okay, thank you. And then I guess what question that I'd like to be able to put out there is, what do you think really are the challenges, especially being able to gain acceptance in a lot of these new technologies that are coming to the forefront, and kind of how important of a role is that going to play in the renewable energy sector? Mark, I think I'll push that one to you.
Thanks, Alice. Well, I think the first thing to say about autonomy is just to recognise the work that was undertaken by the Mass Regulatory Working Group and the support provided by the MCA to get to a place where we have a code of practice that people can work to, that offers reassurance in terms of safety to both other sea users, etc. In terms of the challenges, I think they're multifold. If you start at the person working within an offshore wind company, their reward structure probably doesn't help people innovate. The rewards bases that they receive are generally based on past experience and performance. So there's often no real drive to innovate at that level. You then look at the company itself, and the company may be split into operational and innovation sector, two functions, and the innovation people might be sometimes disconnected from the operational people, and trying to bridge that gap can be difficult. You then look beyond that to the certifying authority, and the certifying authority has to be taken along on this journey and to make sure that they're on board with all the ways of working. And ultimately, most of these things need to be codified under the IEC 61400 series. And if you look at IEC 61400, I think there's very little in terms of structural integrity and how you address that piece. And there's a real opportunity for the industry to come together and really drive something forward. But unfortunately, the pace of IEC regulations is quite slow compared to the pace of innovation.
Okay, thank you. That's an interesting food for thought there. So I also just kind of want to be able to draw attention to some of the areas where we had a bit more of a mixed response. So Alice, I had noted that something that had come forward was the attitudes towards metocean data and its role in improving capacity. They seemed fairly mixed. Yeah, how do you think that industry can, I guess, address that gap between the manufacturers and operators? And are there opportunities for improving the relationships between the data providers and the users?
Thank you, Katrina. Yeah, so building really on what Mark and Ivar have said is that one of the challenges we're facing is that offshore wind is going going to play a vital role in reaching net zero, and we are having to face the problem of expanding our capacity offshore on a scale that hasn't really been seen previously, is almost unimaginable. And so we're bridging this gap between what's currently written in the standards and what's accepted between site operators, manufacturers, and what needs to be developed and innovated and done to get these new technologies and these bigger turbines further offshore. The floating turbines are commercial now, so there's a lot of unknowns that aren't written down that will need to be tweaked with operations and maintenance at these sites. And so moving forwards, like the risk is underperformance, and we need to make sure we're getting as much out of the wind as we can. And how we mitigate that is that we have to make sure that everybody is comfortable and confident with how we're monitoring the turbines, but also monitoring and collecting data. And this is where I think things like the International Energy Agency's wind task groups are really important, because they get everybody in the room, they take away all of the contractual agreements, they strip back the competition, and they just get everyone's brains working on this challenge and the problem and trying to work out, okay, we know where the limitations are, but how can we get around that to get the result that we need to make sure that our turbines are performing as well as they can, and that we're able to be putting out new technologies and understanding exactly how they're working in the environment.
Also, there's something that I would like to address before we move on to one of the other key metrics around safety, largely just in terms of anticipation. Because we've been talking, I think, a lot between other groups, other industries, of autonomous technologies, and a term that gets thrown out there an awful lot is a digital twin, and I think that this either has a broad meaning or tends to be interpreted in a rather broad way. So, and again, I think I'll probably throw this one back to Ivar, but how would you define, I guess, the digital twin concept, and how can that be applied to the operations and maintenance efforts on an offshore wind farm?
That's really an exciting topic, the digital twin in offshore wind, and we see a broad range of developments in that space actually. And the interesting thing is that this digital twin approach and perspective, actually similar to what I mentioned earlier around the supply chain approach in general, is that this is approached from all these specific perspectives. So it's either from the site investigation perspective, or it's from the asset construction phase perspective. If we look at the definition of digital twin, it is actually December last year, December 2020, a final definition was published by the Digital Twin Consortium. You can find that on the web, with an effort to describe it as best as possible in four main lines. But it comes down to a virtual presentation of real world entities and processes, synchronized and specified frequency and fidelity. Digital twin systems, they transform the business by accelerating holistic understanding and decision making. And they use, and that's important, real-time and historic data. And I think that's where the biggest opportunity is for O&M offshore wind. If we take all the different phases of an offshore wind development, starting at the consenting phase, moving towards engineering and construction, and then towards the last phase, which is the longest phase in offshore wind, is the operation. If we bring that all together, all the data from these different phases, into a true digital twin environment, starting with the consenting phase information and the site investigation data that are collected, and then later the as-built data during construction, and then ultimately feeding it with monitoring data, that's providing the biggest opportunity O&M offshore wind efficiency improvements at this stage, and it providing full insight to the asset managers to take decisions in the right way at the right time.
Okay, thank you. And then, just because obviously it was something that was raised quite a lot by the respondents, the people who are taking part in our survey, is that not just considering the technological advancements, but also considering kind of like the needs of the people and the health and safety. So obviously, again, because that was a key message that came through before we move on to the audience Q&A, I just kind of want to make sure that we can address that as a topic. So Panos, I guess, as our safety expert, what were your reactions to the feedback on health and safety? What do you think the priorities should be for reviewing or updating the health and safety policies?
Thank you, Kat, for the question. First of all, I share the concerns of the participants in this survey. But before answering the question, I would like to highlight that we need to take into account some very significant factors. The one is that the industry is expanding really fast. It's an unbelievable rate of expansion. If you check the announcements of national plans around the globe, it's amazing how fast this industry is growing. Secondly, there is a plethora, there is an advent of too many new technologies. Third is that we need to have in our mind that this industry is operating, is expanding in a harsh and a very hostile environment. The sea environment is really hostile. And also now with the commercialization of the floating wind turbines, we'll see the industry will expanding to deeper and to deeper waters, and also to areas that will be more exposed to weather phenomena. And also that we're expecting in the coming future, not distant, but in the near future, to see that the hydrogen, the offshore hydrogen and ammonia production. So all this combined together create a very, very complex environment, and also makes me really concerned that there are too many knowledge gaps. And as the industry expanding, all these new technologies are introduced, there are too many knowledge gaps. So the key for achieving health and safety in order to have a safe industry and to remove any risks for the business and the investments, the key for me is the collaboration. There is no room for competition. So all the stakeholders need to come together and collaborate, and to share knowledge, to share experiences, and develop guidelines and standards. Of course, science will facilitate and help a lot to make this industry safe. I'm not saying that the industry is not safe, but there is a lot of room for improvements. In HSE, we follow a proactive approach. We collaborate with all stakeholders. We organized a month ago a very big global workshop, so where all the stakeholders come together, we share views, we discuss, we identify areas for collaboration, the needs for health and safety, and all this feedback and will help us to develop a roadmap in order to integrate health and safety at the very early stages of innovation and research. So the industry, the academia, the regulator, and the supply chain can work together to integrate the health and safety very early at the innovation. That will help to remove any future risks, will remove any risks for investments, will make health and safety integral part of the business, and because if you develop a solution and at the later stage you need to make changes or adaptations in order to make it safer, to adapt health and safety practices, this might have a very big cost and also remove the desire for investment. So to answer this question, the key is the collaboration and the proactiveness, and to work together to integrate the health and safety early enough, innovation and research. Kat?
Okay, thank you, and obviously thanks everyone for giving your initial thoughts on our results. I think I'm going to move over to our audience questions and take some Q&A from our people online. So I think this one is probably aimed at Ivar, but I will obviously throw it open to the whole panel. It looks like it's a follow-up to your point on the digital twin. So this question is from Leroy. It says, can digital twins be a major development, in particular for offshore wind, given its recent advancements? And does the panel see this as a tool for future cost saving?
Yes. No, yeah, there's only one answer possible to that question, and that is yes. We see it as a huge opportunity. One of the things that we've recognized is a relative disconnect between the different phases in development of the offshore wind farm, as I mentioned earlier in my last response. We feel that integrating all these data and making them available to the O&M teams for decision making in their O&M efforts, I think there's a huge benefit in moving in that direction. And it is actually already recognized by several operators looking at this space and how it could be given shape actually.
Okay, thank you. And did anybody else kind of have something they wanted to add there, or?
I think it's worth noting that a lot of the turbine manufacturers already operate digital twins of the actual turbine. It's a support structure and foundation that needs the work.
Okay, so this question was submitted anonymously, but getting people access to offshore turbines for maintenance was historically a challenge. Is this still a problem, and what's the prize from better Metocean?
I can go for this. Yeah, I think it is still this challenge. It's a very big challenge. I don't think that the industry has solved this problem. It's an area of major concern, and the situation is becoming more difficult, especially with the floating wind. So where you can have moving platforms. So how you can have people safely to get access to these moving platforms, and how you can have people working these moving platforms. So it's a big area of concern, but also this is an area of scientific collaboration and research. So we are working with academia. We announced floating, especially for the floating wind, we announced a network hub. So we invite all the stakeholders to join this hub, so we can discuss these areas. But also this is also an area of further development, technological developments, because there are solutions there. You can apply solutions to stabilize the vessel, to stabilize the moving platforms in order to allow safe access to the platforms. Kat?
Okay, thank you, Panos. And again, were there any other thoughts from the rest of our panel?
I think the challenge here is individual waves, predicting the individual waves for people to get on and off the platforms, and the broader Metocean observations don't really help with that. So it needs some specialized technologies, and a number were funded, but I'm not sure that they have proven to be overly robust, shall we say, or cost efficient perhaps.
Okay, thank you. Okay, so looking back at our questions, Again, this one was submitted anonymously and it's not aimed at any particular speaker, so I will throw it out to the floor. GIS storage of data and sharing of information and lessons learned should become mandatory. Mistakes are not repeated, so that mistakes are not repeated again. Do you agree with this? Yes, do you think there is, I guess, how much of a role is there for improvements, I suppose, in data storage and sharing, and what do you reckon that there are the sort of key lessons learned from other experiences, and whether or not that should become mandatory?
I'll go first.
I can give a first go at that. Alice, you want to go ahead, Alice?
I can see everyone's itching to go. My main comment was just to say that I think a lot of improvements have been made and certainly are being made going forwards. There's been a consensual effort to get metadata made standardized so that it's easy to access and put into different systems. There's been standardization of data formats to enable wider access of data. And I think going forwards, there is certainly a number of calls to share and be transparent with data as much as can be to help this innovation and to help us expand. So I'm hopeful that it's going to happen because certainly it looks like there are mechanisms in place to pave the way. So go on, Ivar. You look like you're ready.
With Fugro being a geodata company, obviously data standardization is at the top of our list, and we see a huge benefit in that because it will allow the industry, it will allow the market to cooperate in a more effective way, more freedom for the operators how to approach their supply chain. But that's a challenge with different equipment manufacturers, different data formats, etc., etc. I mean, looking at it from for example, geophysical perspective alone, the variety in data formats that is available to acquire geophysical data is enormous. So standardization, yes, huge benefit. Data sharing, I think, would also be useful, but there we are facing the challenge that in the end, the wind farm operators are have their own business space, which they need to maintain, and data can be of huge value in their business model. So that's a sensitive one, where I think there will be challenges with regard to sharing data.
Okay, thank you. And we've had another question come in that I think relates here, which is that a lot of operation and maintenance opportunities that we've discussed here are also desired opportunities for the oil and gas industries, with a mixed benefit seen so far. And is there a sharing between these two industries to develop these tools?
I think there will be. We've seen all the majors moving into offshore wind, particularly in round 4 in the UK. I think perhaps oil and gas is slightly further ahead in terms of survey work being conducted by autonomous vessels, and that's now being brought into offshore wind. So certainly there's a lot of cross-fertilization there, and I think there's also a lot to be learnt from the structural engineers within the oil and gas industry. There's perhaps more dynamic nature to turbine support structures, but there's an awful lot to be learnt, and that is also seen in the metocean side of things, where IEC's really taken an onshore wind package offshore, and it doesn't quite tie up with some of the ISO 19901, which is based on nearly 50 years of history of working offshore in the oil and gas industry. And that's another area that the IMarEST has looked at with Gus Jeans's presentation a few weeks back.
Okay, thank you. So again, this is another question put in from our audience. Are there different patterns in national regulations and priorities, and how much of an impact could this have on how the sector develops?
Yeah, I think we see we see a variety in progress of development in offshore wind in the different regions, with Europe far ahead, and with APAC and the Americas following. So in general, that has an impact on how developments are received and how O&M is approached. But the good thing there is that most of the major players that are active in these developments have a global footprint. So basically, the players and the supply chain, they are moving together in certain directions. So it's more the local authorities we need to step into that space. If I look at, for example, remote and autonomy development, I mean, it came across already in a few previous questions. What we see there is a technology which is there. Yeah, technology-wise, I think the industry is capable of running remote and autonomous operations in an offshore wind farm. But what we are facing at the moment is the regulatory framework, which is missing to facilitate that in a smooth way. It is possible, but the local regulations simply do not facilitate day-to-day uncrewed operations with the uncrewed service vessel, with a USV, or with a UAV, with an aerial drone. That all needs to get in place. And I think that this management of change process is something that needs top attention by the whole market, and that requires a cooperation between the operators, between the supply chain, and the regulatory bodies who shape this legislation.
If you can allow me, I can talk about the UK. There is a stable framework for regulating this industry. HSE and MCA and Ofgem are collaborating. There are discrete jurisdiction areas. When there are overlaps, there is a framework where there is collaboration. Of course, when there are also problems, the channels of communication are open. We have a very good collaboration with MCA. I know for sure that in European level there is a European project called the wind harmonization. So in order to address all the different jurisdictions risks, because this industry is international, and the people working on this can move on from different jurisdictions, and this creates a lot of risks, a lot of contradictions. There are health safety risks because of the different compliance requirements. So at the EU level, there is a lot of work to be done. For ourselves, we support other governments, other regulators, international level, to develop their regulatory capacity in health and safety in this industry. But again, the key is the collaboration. Keep the channels open in order to discuss and to ask people to let them know about the problems. Kat?
Could I just point out there's also some discrepancies within national regulations due to different regulators. So if you look at offshore wind and you want to put a met-ocean buoy out or a FLIDAR system out, you're probably looking at 10 to 14 weeks to obtain an MMO license. if you want to put a metocean mooring out for a CCUS project, you're probably looking at 4 weeks to gain the license. So there's some discrepancies there too.
So we have had a similar question, which may have kind of already partially been answered, but I'll sort of put it out there for any further comment, is that in oil and gas, system maintenance is heavily driven by regulated integrity requirements. What are the regulators' main drivers for operations and maintenance with regards to offshore wind?
Yeah, there's a variety in how this is approached. For example, on the German shelf, there is a requirement to inspect at a certain frequency. So the assets need to be inspected, I think, if I'm not mistaken, once every 4 years. I do not know of any other strict regulations like that, but it illustrates that there are quite some differences in how this is approached. And actually, looking at the oil and gas asset integrity approach, for example, with regard to the subsea pipelines, the responsibility is put on the plate of the operators, and that has been interpreted as a requirement to, for example, inspect pipelines on an annual basis. But in the end, the essence of the regulations and the laws that are written are more focusing on putting this responsibility with the asset owners and making sure that their assets are stay in a healthy shape. And I imagine that with regard to offshore wind, where the environmental risks are actually much lower than compared to oil and gas, this is approached in a similar way.
Thank you. And okay, I have a question on how do you see the development of edge analytics being used in the OWF, which I'm assuming is offshore wind farm environment? With limited connectivity back to the central cloud. Sorry, the question jumped around there as well. I had the voting coming in, so I'll do that then again without the gap. So how do you see the development of edge analytics being used in the OWF environment with limited connectivity back to the central cloud?
I think the challenge there is having all the data in the right place. I'm not sure that all the data that you need would be offshore. You might also need some modeling data that comes from onshore. You probably want to look across the assets, not single assets. So you could potentially put the edge analytics on, say, a substation where all the turbines within a single field are reporting back to that. But I think you probably want to bring together more data than just what you're collecting in the field.
Again, we've had quite a few comments and questions coming in around the idea of data sharing. I've had a question here from Robert Barnes asking, will offshore operation and maintenance data be joined with the oil and gas data from DNVGL's existing OREDA system set up around 30 years ago? So I guess then question reaching out is how much awareness is there of that system, and would there be a relevance or a benefit in being able to share that data from oil and gas with offshore wind?
I think the concept is good. I'm not sure that it would be exactly the same, but certainly bringing data together, the challenge is where you have potentially designs that are optimized by a certain operator and they don't want to share the information with others. So it would be may fall into issues with data sharing, but the actual concept would be great. So that the whole idea of machine learning and not having a big enough database, if you can pool everything together and look across things, but I'm not sure whether operators would wish to do that.
Yeah, we have had quite a few comments coming in about how it can be, data sharing can be sensitive. And there was one question in particular saying that obviously in view of the current climate situation is encouraging that kind of sharing, something that's going to be a topic of focus at COP26. I'm not too sure how much awareness you'll have of the discussions being planned for COP26, but I think it's within that question itself is if that kind of thing being encouraged will also be in light of a lot of the aims and goals of the upcoming COP. What do you feel there should be the priorities for offshore wind to be able to support those? Alice?
Yeah, so I guess I'm not sure if I'm going to answer the question in its entirety, but I think things like the offshore wind energy, the Global Wind Energy Coalition that have been set up in the run-up to COP26 are going to be really key and crucial to us meeting our climate targets, because they're really crucial to getting all the main players in a room sharing and talking. And I think with COP26 in mind, the challenges being data sharing and transparency will be clear across the board. Now, what goes on behind closed doors versus what goes on in the published world, it might be quite different. So they might be sharing things behind in those conversations that they might not be publishing, but either way it will be helping facilitate the development going forwards. But yes, I think it is a good topic for discussion. How do we promote data transparency whilst maintaining commercial confidentiality?
Just going back to Ivar's point about having early data, all that data is available within the UK through the Marine Data Exchange. So there's a wealth of data in terms of geophysical, metocean and wind resource data and environmental data that's already shared. It's the next step where you're looking after assets that the data isn't shared.
Okay, so we are, I think, starting to come up to time. I'll look at doing one more question and then I'll do a round table just to get closing thoughts from our panel. So yeah, I've got one more question from our audience. Local wave radar data integrated in the DT predictor be an approach for predicting individual extreme waves. I'm guessing that's local data be a suitable approach for predicting individual extreme waves. So, yeah, I know it was mentioned in the comment earlier that being able to predict or being able to have a better understanding of and management for kind of those extreme events would be a challenge. So how?
I'm not sure if this relates to design in extreme ways or getting people onto platforms, but it is not just the wave you have to measure, it's actually the vessel motion. So you need to be able to accurately predict how your vessel is going to respond to a wave. So it's challenging.
Okay, and with that, we've got 2 minutes to go. So I know we've had more questions than we can answer, but just like to say, obviously, thank you again so much to all of my wonderful panelists for joining in this discussion today. And just as a closeout, I'd like to again sort of go around and sort of ask each of our panelists just to give, I guess, your closing thoughts on kind of given the survey results that you've been through and the discussion that you've had today. What do you think are some of the key take-home messages, I suppose, on where the future of the industry is going? And again, I'll go around my screen. So Ivar, would you like to kick us off?
I stay on the top left of your screen. No, thank you. great to be involved in this, and the survey provided a huge amount of really interesting insights. And yeah, looking forward to work with the industry to further shape offshore wind O&M solutions and contribute to the energy transition. So thank you.
Thank you, and Anna.
Thank you, Kat. Yeah, I've had one eye on the Slido questions as they've been coming in, and I think something that from the survey and from some of the questions that have been asked that's really kind of focused my mind is that we need to have, although we're very focused on strategy and targets, but actually we need to think about the workforce and the individual and making sure that there is transparency both between companies, operators, but also between the workforce, and particularly thinking about green transition and digital literacy and making sure, yes, we've got our graduates coming up being trained in all these innovative solutions, but we also need to make sure that our current workforce is trained and skilled, and so that's where maybe some skill transfer across the higher kind of career status ladder would be beneficial. So more support there perhaps. So innovation on both sides is required.
Thank you. Mark.
Well, first of all, I'd like to thank Fugro for initiating this survey, because it has given us a lot of food for thought as chairs of the Offshore Renewables SIG and some of the future events we might hold with regard to workshops around some of the outcomes of this survey. I think we have to look to the history of offshore wind and how it's moved in terms of JIPs and research to reduce the cost of wind, because I believe that this industry is innovative. It can make massive steps forward and really address some all the issues that have come up in this survey through the application of relevant technologies. So I'm very hopeful for the future.
And Hannah.
Yes, I think the survey and the webinar, all these discussions are very, very important, very, very useful, creates a lot of insight, brings closer all the stakeholders, all the interested parties together to create a room to create forums to discuss all the topics. I would like to mention that this industry is bringing a lot of investment in new technologies. Technology is good from any aspect, but we need also to keep our focus on people. And I'm talking for the workforce, but also for all the communities involved in the development of this technology. It's impossible to discuss for sustainability without having people on the picture and on the central focus.
Okay, thanks all. And again, apologies to everyone online. I'm 3 minutes over. So with that, we will wrap up for today. And we do hope that you will join us again for more discussions and events coming up on IMarEST TV. And with that, we'll say goodbye for now.